Slow to Go, Rails Test Profiling Hands-On with Vladimir Dementyev. Vladimir is a mathematician who found his happiness in programming Ruby and Erlang, contributing to open source, and being an evil Martian. Author of Any Cable, TestProf, Ruby Next, and many yet unknown ukulele melodies. Please welcome to the stage, Vladimir.
Thank you. Let's check. Okay, that sounds good. Before we begin, I'm gonna repeat one more time. If you have problems with installing and setting up stuff due to slow internet connection, I have a few USB sticks you can grab and copy everything we need from there. So feel free to come and grab one. Okay, let's start. We have just 2 hours and really, huge plans for this code base. Okay, so we're gonna do task profiling today. It's really cool that we had this keynote this morning on, I would say, general profiling for Ruby. And I'm glad that John already, I hope you saw it, because there are some important things like what is sampling profiling and how do we analyze flame graphs and all that stuff. Because we're gonna do that in the first third half of the workshop. That's what we're gonna start with. And I'm gonna repeat a lot from there. So while, if you haven't tried to run the test yet, please do that now, and just to kind of commit your initial results to see your progress. There are also paper blanks on some tables. There are probably some spares. If you do not have one, please ask if there are some lefties over there. About 100 of them. And I want to quickly start with some, while you're dealing with setup and running tests, let's talk about why we're here, first of all. I assume that if you came to this workshop, then you probably consider your application tasks slow and you experience some problems with that, and if wish they could be faster, either when you run it locally or on CI. And that's actually 2 primary reasons to optimize tests. We want to avoid longer CI builds, which sometimes also could affect our expenses. And actually longer local CI builds, that's a new thing. And I'm sorry, it's common to Rails world, but someone wants you to run your tests locally. And we saw the results, if you check the thread in the Slack, that for this code base, and it's a real code base, you're probably familiar with it, with the project, it's anywhere from 5 minutes to 15 minutes. And yes, we can just give everyone a free Mac laptop and probably 5 minutes for pushing code. It's fine, but 15 minutes is definitely not an option, but we're gonna make it better. So I'm not talking about local builds mostly. We still want to optimize both sides of it. I'm not assuming running the whole test suite locally, but still you run tests locally, even running a small subset of tests should be quick enough to avoid distraction, to make your feedback loop faster, and thus make you more productive, because that's the reason why we choose Rails, right? We want to be productive. So the process of kind of making tests faster is similar to probably doing any other optimization work. First, we need to identify what caused the slowness, and then we need to apply some patch to take a pill, and we repeat until we're satisfied. That's interesting. When you should be satisfied with your test, we're going to talk about it in a second for a bit. But one thing I'd like to start is about the identification, or how to identify problems in your tests. And one may assume that, okay, we have profile flag in RSpec, and it has been recently introduced to Rails Test Runner, and you just run it, you see the top 10 slowest tests, and you go and fix them, right? But that's not the best way to do that, because usually optimizing the slowest test takes a lot of time. And unlike optimizing production code, you don't have enough kind of budget, time for optimizing tests. It's still not something user-facing, user-related, and it's hard to convince your like product manager or whatever to spend sprints on optimizing tests. So the test optimization differs from production code optimization in the sense that you want to fix things kind of faster with less possible amount of refactoring. And that means usually making, as Stephen Baker, the author of RSpec, said that making often use things faster. And that's lead to the situation when we need a specific profiler for tests, and that's TestProf, which we're going to use today. That's why it was created and been used for years by Rails applications mostly, because dealing with tests is a bit different from dealing with production code, because there are some patterns that are pretty common, but still hard to find, and we need some tooling to help us with that. And as I said, TestProf has been used by many companies, many well-known companies, and you're going to be on the list if you want after this workshop. So I am the author of TestProf. My name is Vladimir, and I do some other open source work, and that's not related to our today's talk. I'm working for a company, Evil Martians. We do office hours at Hack Day. Feel free to come and ask any questions. And final, like advertisement beats. I have my book on the story graph. It's like solid technical read. I don't know, like it's 4 stars, you know, from Andy Crow. Probably the same Andy Crow that was joking yesterday. So 4 stars. That's good. I think it was reading. And we haven't made the offers block somewhere at the lunch when I don't know what I'm gonna do that, but I have some copies and stickers for my book and sorry. Okay. To answer any questions related to the writing. But today we're focusing on tests, and we're gonna deal with Mastodon. That's surprising that John also mentioned that he set up his own Mastodon instance just to play with it at the Ruby application, to try the profiler, the Vernier, to use it with it. And I also decided to use Mastodon to kind of experiment with TestProf on some random project, and the one that open sourced and could be used by anyone. So to feel this feeling of like profiling something real, not artificial. One quick disclaimer: as you can see, we're not using like Mastodon repository as a source code for our project. We have a history-less repository. That because Mastodon is actually already using TestProf, and they applied several important optimizations, and I had to revert them to make this workshop more fun. So we're gonna rediscover them again and probably fix them in a bit different way they fixed in the original code base. But good news that they're gonna be some stuff that is not yet applied to the Mastodon code base, so you'll be able to contribute to it after the workshop. Okay, so the plan. It's the kind of the profiling work we're gonna do today could be divided into 3 steps. First is general profiling, as I call it, like profiling test as any other Ruby program. And that's why we're gonna use Vernier and Stackprof. Then we're gonna use TestProf specific profilers to narrow down the search for bottlenecks. And finally, we're gonna deal with factories. And that's going to be the last part. I hope we reach it today. Yeah, this is my results, for example. I spent like more than 2 hours, frankly speaking, because I was dealing with spoiling the code first and fixing it again. But I got my local time from 8:30 to 2:30. So the same gparspec command you're using, I hope you're using today. I shared this paper blanks just, if you want to track your progress, share it on Twitter, whatever, just for fun. I wanted to add some interactivity to this workshop. And I also tried to run the test suite on CI using the same CI setup that Mastodon use. And there I got about the same difference, but the absolute numbers are not the same, right? That's because CIs are more complicated. We have different phases. We have setup, installing or restoring dependencies, and so on. And we have some parallel jobs within the same testing workflow. And that's partially answers the questions when to stop optimizing Ruby tests. It's when it's no longer in adding any valuable improvement to your CI build, because you have other components that could be slower. So if you have tests running like 1 minute, you still have like integration tests running longer, or some other checks or whatever. So that's, in practice, that's a target goal of test optimization. You try to make all your CI components run about the same time to not have the outliers that slow everything down. Okay. And we're about to start with general profiling. And I already mentioned we're going to use Stackprof and Vernier. I want to add the very first slide explaining what these profilers doing. Yeah, thanks to John. So these are sampling profiler. That means they collect stack traces over the time while your program is being executed. And we analyze the frequency of every method being called. We analyze the call trees, hot paths. And that's how we can find some common issues in your test setup. General profiling for tests is really helpful to find some misconfiguration problems. You have something configured improperly for tests, and that slows everything down. Okay, I'm gonna stop with slides, and we're gonna play the game. Is this font size big enough? Okay, let me start the container. So this is how I open the terminal within the container. It has this whale. Okay, let's make it larger. Maybe one more. How about that? Should I stop at this point? Okay, let's just check that everything works. Within the container, I use this command. B is bundle exec alias. RSpec. Let's try to run some model tests. User spec, for example. Let's just to make sure everything works. I'm gonna take some time to warm up. Yeah, okay. Okay, just nice. Now, before we're gonna start with sampling profiler, I want to tell one thing. I probably already mentioned in the keynote, but yeah, we can run Stackprof to profile the whole test suite, but since it takes for you from 5 to 15 minutes, with profiler overhead added, it's going to be like 15-20% higher with Stackprof. I'm not sure about Vernier actually, and haven't measured yet, but we don't have that much time. That's just to wait for tests to run. So we need a different, and that's kind of smaller code base, like 5,000 examples. Like if you have like 20,000, you're never gonna run the profiler against the whole test suite. You need to figure out how to use it for your test. And the best way to narrow down the scope for the whole test suite, just to pick a random sample of your test of a fixed size, maybe repeat it multiple times, like like you do in any statistical work, and analyze, aggregate the result, and analyze them. And that's where we first meet TestProf. So TestProf is already added. Okay, let's play this fun game again. Okay, so we already have a bunch of profilers added to the development test group in the bundler. We have memory, RubyProf, Stackprof, Vernier, and TestProf. So you don't need to add anything. You don't need to run bundle install during this workshop. I pre-installed everything for you. So what I want to do is to add this sampling feature to RSpec that will allow us to run a random subset of tests without like manually selecting them or whatever. And it could be done with just a single spell. Require TestProf. Oh, even Copilot works. That's not what I was looking for. Sample. Okay, TestProf recipes RSpec sample. Wow, it's a bit long. As you can imagine, it also works with Minitest, if you replace it with Minitest. And let's give it a try. So the way it works, and the way all the TestProf tooling works, you just define an env variable and run your test. You don't need to change your code to start profiling something or whatever. You just configure TestProf using env variables. And we just run the whole test suite. you see that the formatter, the reporter, show that we have 5K examples, but it's going to stop as soon as it reaches 100. Okay. The good thing about this sampling feature is that it recognizes all the filters and other settings of RSpec, so we can use it run it with the same seed, and it's going to be the same subset of your test. That's useful if you want to measure the difference between some configuration changes when doing your profiling work. So that's sampling. That's what we're going to use with Stackprof and Vernier. But before we do that, I want to quickly add the very first optimization to this test suite. You see that RSpec finished its work, but it took, I don't know, 5 seconds for coverage report to be generated. But we don't need a coverage report for a subset or a single test. We actually don't need it at all. Okay, that's a different story, but we don't need to run coverage on every test run. Maybe from time to time just to monitor the state of your coverage. But it's definitely useless for every run, and it has a lot of overhead. It's about 15-20%. Let's take a look at our spec helper already open, and we see that in Mastodon code base they have coverage opt-out kind of functionality. So you need to explicitly tell them don't need coverage to disable it. And I consider it's like a very bad anti-pattern, and we're going to fix it because coverage must be opt-in. Okay. And with this, just a single change, let's just measure the difference. So we had 10 seconds something and 8 seconds to load. That's actually important because coverage affects the load time as well. And now we can run it again with the same seed. So it's going to be the same set of examples. And see what the difference. Okay, it's 9 seconds 94 and 6.5 seconds to load. So yeah, about 15% improvement. And for the whole test suite, 15% is huge, especially if you're doing local CI stuff, right? So that's the first suite we fixed just to make our test faster for the rest of the day. Now let's start with actual profiling, not just eye profiling. That was actually zero version of profiling, like eye profiling. You just spot some stuff and you fix it. Now let's run, well, probably using the same sample. Let's continue using it. Let's run Stackprof first. To generate a Stackprof profiling report with TestProf, all we need is to tell it to run Stackprof like this, test Stackprof 1. Yeah, that's not the best interface, but it's hard to introduce custom CLI flags to RSpec, unlike like with many tests we can do that, but with RSpec we have this unvariable workaround. Okay, TestProf shows you that the profiler is enabled. It has vol mode for tracking time. Already, vol. We have different modes. I'm usually using vol mode because that's what you see as a developer when running tests, and it has some output information. So it's a row dump you can use with Stackprof CLI to see call graphs and plane profiles. But the best way to analyze Stackprof profiles is to use the JSON format and open it with SpeedScope. We can open SpeedScope on the web. Let's probably try this. Okay. Okay, it kind of works. What we just generated, I think this one. Yeah, so these are flame graphs. So these are our code stacks in the time order, though the way they were collected one by one. So we have this, see that there are some gaps. If we try to zoom in, we see that there's garbage collection. That's one of the things I kind of don't like about time order Stackprof profiles, that garbage collection just breaks kind of wide spans into multiple pieces, and it's hard to focus on them. So time order is not really helpful here. Lift heavy aggregates common stacks and shows you some patterns in your code, like garbage collection. Actually takes a lot of time. It's There is also a technique of tuning garbage collector for tests, actually, that could improve this behavior because, yeah, it's really long, like 10% of time garbage collection. But I haven't tried for this setup. We can see the phases of execution. We have Rails RSpec runner setup. We have run specs, and we can trace it up to the individual specs that were executed. We can trace the setup process with like, you have some interesting stuff here, like, oh, this is a test probably. And there you can find like Rails application initialize. It's useful to profile, let's focus on that, to profile boot time of your test. You can find some initializers probably taking too much time and probably they're not needed in test at all. You can disable them and so on. That's how you work with this view. And but the most useful for long hanging fruits in terms of optimization is a sandwich view. It's kind of similar to the inverted stack demonstrated by John for Vernier. So it shows just the frequency of every method that was appeared in the stack. And here we can find some interesting stuff like thread queue pop. You can click on it and see where it comes from, some debugger thing. Well, that's suspicious, I would say. Let's actually take a list of suspicious things. Okay, sampling profiler. Debugger. What it's doing here, why it's on the top. It takes a lot of time. Bootsnap. So we're using Bootsnap to speed up files loading, Ruby files loading. And I don't think there's anything we can do about it. Skipping. Garbage collection. We already talked about it. Then we have IO select, and we can trace it to the paperclip. Oh, so they're using paperclip. Yeah, sorry for them. And we see that there is some processing, terrapin command. So we can actually find the same kind of stack trace and process found. So this is file transformation, which is enabled in test. And paperclip, I don't like about it, it has no like test mode, like carrier wave or shrine, for example. They all have some kind of a non-processing mode for tests, but paperclip doesn't have this feature. And we're gonna figure out what to do with it later. So let's add paperclip on the list. Okay, what else? We have PG connection exec. Well, that's active record. That's a lot of it. And that's something we cannot fix only by the configuration means because it's used kind of everywhere. We need to find a different way to limit the number of SQL calls in our tests. And that's going to be in the last part of this workshop. Well, a message package comes from, oh no, it's not, it's actually Bootsnap, and it's I89, so it's like from internationalization, sorry, internationalization, and it's loading translations. Let's talk a bit, take a quick look into the this problem. So if you open the folder with locales, how can I do this? Okay, it's very visible. Let me just show you something. We have I18 and load path. So load path collects the paths to all the translation files available to the project. And let's take a look at the size of this load path. It's over 1,000 of YAML files that are being loaded whenever we initialize the translation backend. I'm pretty sure we don't need that much like locales for our tests. We probably need like 3, 4, 5, because there are some RTL languages being tested. But we don't need that much files. Probably reducing the amount of locales would also speed up the boot process, so we can avoid this heavy reading and unpacking calls. Also, we have bcrypt. Bcrypt comes from device encryptor. It's how we encrypt our passwords. And if you open the device RB file, we have this config stretches setting telling how many rounds of encryption must be accomplished to encrypt passwords. And it's already set to 1 for test environment. That's a default in device. So we cannot lower it, and it's not a big overhead. But one thing I would recommend to try, probably after the workshop, try setting it to some greater value, like 2, 3, and see the difference in the test run time. It's going to be growing faster as long as you increase the value. And one thing to know about this big crypt, or sometimes S crypt, whatever crypt thing you see in the stack trace, in the sandwich view or whatever in your profile, is that make sure that you're not using production grade values in your test setup, because some people use custom encryption features and they don't think about it. But then if you do profiling, you can quickly identify this problem and speed up tests drastically. Well, and I think last thing I probably want to point here is JSON parser parse, and it comes from Webpacker. Let's just add it on a list, and we later figure out what's going on there. And I will demonstrate it using Vernier, because the just introduced Vernier prof with this support for source code viewing is really helpful, because the local version, this profile viewer gem I ask you to install, doesn't add this feature, only the web version. Okay, what we can do here, we can actually sort the methods here. So right now it's sorted by the total amount of spent within this method, including internal calls. But we can actually try the other way around and try. Okay, no, that was sorted by self. Now we try to sort by total. And obviously, like bundler ClearStart is kind of main. It's the one that wraps everything. But if we kind of scroll down a bit and ignore all the, RSpec and kernel methods, we can see that, fabricate creates for 30% of time creating factories. We can see it here right now. What else? What else can you spot it? Is anyone running the same profile locally, or are you just watching what I'm doing? And quick question. Yeah.
I have a question. I understand how you're kind of filtering on the left. How are you reading the side on the right?
So the side on the you mean this? Here. Can you see my? Yeah. This one, the method names, or this one. Okay. So this. Just a portion of flame graph from like lift heavy view, for example, which shows you where this method comes from. So where it's been called, like how many, like so this is a method, and these are all the stacks that reach to this method. So we can see that fabricate create. That's actually a good point. Whenever you see a lot of different stack traces here on the top right region, that means that something is used from pretty much anywhere, and there is no one way to fix it, like one place to fix it. So you need to approach it differently. And that's you can track down to where it leads. So what else do we have here? I will try. Okay, we have Sidekick client push. That was what I'm looking for. It also like 11% of time. It's hard to spot in the sandwich view because the actual client push method is pretty quick. It's like empty method almost. But its aggregated kind of a value is noticeable. And we can see it's also being used in many places. Almost with active record related. So I would suggest that's, there, run callbacks. So we have job and queuing and some callbacks in our models. Okay. And which is also usually not required for tests. So we're going to work with Sidekick as well. So this is Stackprof and speed scope viewer for it. I don't think there is anything interesting to focus on. Let's try doing the same profile with Vernier. Okay. And you might guess the command is going to be about the same. We just tell test Vernier. And it says, okay, Vernier enabled globally. So enabled globally means that actually TestProf provides RSpec integration to mark a particular example or group with a tag and profile just a single example if you want it. But it's, frankly speaking, it's rarely needed feature. Okay, and we have, Vernier takes some time to convert the profile into JSON. So we have it here, and we can upload it here. Okay, let me upload it first. Okay. So no, I'm opening it with the web version right now, because web version supports looking at the source code of Ruby gems, and local version it doesn't support it yet. So yeah, that's the difference. It's so local version of the profile viewer is like a backup plan, but it's the web version is more convenient. So okay, we kind of already know a bit about Vernier. It also has the same flame graphs. I don't know why it's kind of, I don't know what's the problem with fonts. Anyway, what we gonna learn new things. Okay, let's invert call stack, right? Let's do this trick. And we have about the same sandwich view as we had here when we profiled self. It should be really the same, right? Fred, boots, is it? Okay, let's, yeah, okay. Hide this one. So Fred, Bootsnap, IO select, process spawn, almost the same. We don't have GC here because it's in a marker table. I'm going to talk about it in a minute. But here we can track it where it comes from. So debugger. Okay, let debug Fred client, and we can click on it and okay, see the source code. Cool, that works. It doesn't tell me actually anything. So it's like some loop within a debug gem, but still it's strange that it appears on the top of the list. We do not do any debugging tests right now, right? But it's there. And IO select leads us to terrapin. I don't know, what is it? Something used by paperclip. Let's go, yeah. Convert, identify, and so on. We can probably also see that it's just running a command on the host machine. And what I was looking actually is JSON X parser. And we go all the way to Webpacker. And here we can see that it's coming from the load method of loading the manifest. And manifest for the Mastodon code base is kind of huge JSON. There are a lot of assets. But why it's being called frequently, right? The reason is this line, config cache manifest. Apparently, it's set to false for test environment. So whenever we try to access assets data, and actually we can track it further to, okay, probably it's better to open. Okay, we can focus on this subtree only and open the flame graph. No, it's not synchronized. I'm sorry. Yeah, I'm still new to this Vernier thing. Okay, it's asset path. So if you have many assets in your request spec, which are rendering views, you call Webpacker, it tries to parse JSON, load and parse JSON every time you access it. And that's something we can quickly fix. Let's open Webpacker YAML and just copy this cache manifest true. That's it. So like just a single line of code. And this thing will disappear from the final profile. We're gonna run it later. Okay, let's go back to full range. It's not working. Okay, here, okay. What else? Let's talk about debugger. And maybe we should take a look at the tracks panel. And this, wow, we have a lot of threads executing in our tests, like threading helpers. Looks like they have some threading tests, and they got into our sample. But you can take a look at the okay. Yeah. So with Vernier, we can actually show all tracks. We can see all the threads. Yeah, I don't see them. Okay. And this is our main thread. This is the top one being executed almost always. There are some additional threads. It's probably short-lived threads. And there's a lot of information. I don't know how to hide. Okay, we can delete them. Yeah, we don't need them. Let's delete them from the view. Yeah, because I was looking for this one. It seemed that there is a debugger thread, some kind of a background thread, but it does a lot of work. a lot of useless work. And the thing is, we need to kind of, zoom in, I think, a bit. Yeah, it's kind of running slow for me. So we can see that this blue indicates when this thread is active and when it's waiting, blocked by some other threads. And we see this, there, it was probably try to open marker table. Okay, it's not visible. So, oh, it's table, it's not a chart, a marker chart. And we can see which thread was running when and why it was blocked and what it was doing. It was doing thread queue pop. So we're just waiting for something on the queue, for some event. And it seemed that the debug gem kind of patched some Ruby methods, like kernel methods, and tried to hijack the execution whenever you start a debugging session. But it checks for it frequently. So and this checking is actually blocking. So it blocks your main thread from being executed due to GVL. So what we can do to fix it, okay, here we go. We need to find the debug gem and just set require false. I don't need it for all my tests. If I want to run my test with debug capabilities, I can run brspec minus -r debug and load it when I need it, or just require debug in my code. But by default, I don't need it, especially if it has some overhead. So that's another thing we're going to fix kind of quickly. Vernier allows us to see the reason why there is slowdown due to the debug gem, just because it's occupying the GVL for some time. Okay, what else we were thinking? So this one kind of fixed this. I think also fixed. What else do we have here? Paperclip and.
Excuse me, you say it's fixed, or you're saying you know how to fix?
We're going to verify it. We're going to run the profile one more time to make sure that it disappears from the profile and the tests are faster. So let's see. So we disabled debugger, so it's not loaded by default. And I hope it should be enough to stop it from polling the thread for some kind of events. Probably if you have required debug in your code, that wouldn't be enough. But in our case, I think it is. And we enabled caching for Webpacker. And now we can retry our profiling. Let's use Vernier again. And to create this different version, like different JSON, we can tell TestProf report to use a custom suffix for this. Let's call it no debug, no Webpacker, cache Webpacker. Okay. So we're going to have two files and we can compare them later. There is an option in TestProf to add timestamps to a regenerated profile by default. It's also useful, but it requires some manual, like some writing some code in the configuration. Okay, so we have a new profile. Let's load it. Let's load it to Vernier. Okay. And let's do this in vertical stack stuff again. Yeah. So we see that there's no thread queue pop anymore. We don't see any JSON, at least at the top of the list. So I think it seems to fix. Let's just try to see the difference. Even with Profiler, the difference is like 10.5 and 8.5. But that's with profiling overhead, so we already had 8.5. So it's cut another like 5, maybe 10% of time from our test run. And the Webpacker thing is only affects specs relying on views. So if you measure the difference for, say, request specs, they're going to be a bigger improvement. But on average, it's like just be it spread out between other tests. It's not maybe it's not that noticeable, but still it's an improvement and it's just a line of code. That's kind of the main principle of optimizing tests, like doing this first iteration of test optimization using sampling profilers. you want to find something that easy to fix with just a single line of code or like just a couple words of code as with debugger. You don't need to dig deep into stack traces and locate some really difficult bottlenecks. They're not worth it. We're gonna find another way to fix that. But at least we identified other problems, right? We found Paperclip and Sidekick as potential candidates for improvement, and that would require taking a look into the code a bit and writing some code to fix them. But that's going to be the next step. Okay. Please tell me if I'm too fast. I'm actually not following time. We have like 40 minutes out. And if you have any questions related to, if you tried to run Stackprof or Vernier, maybe you discovered something else you would like to share, that would be also good to know. You mean running profilers? Yes, I think I will share it. It's in a slide deck, and it's actually, if you have a like paper blank, it's on the other side of it as well. Oh yeah, what a surprise! You know, paper is still useful. Okay. Let's continue with slides, I think, just to recap what we accomplished during this part. Okay, before we continue, okay, I want to ask you to drop this piece of code into your Rails helper. Yeah, take a second to capture it. Or I actually need to do the same, so let me open terminal editor. So Rails helper. We're gonna profile that. We want to know how Paperclip is really bad for our test suite. Somewhere before RSpec configure, it doesn't really matter, but I try to put it closer to configuration. So it's TestProf, event-prof, and I forgot what's next. Monitor. Yeah. So monitor is actually kind of it just set up an instrumentation for this method. So we call the class big attachment. No, not save destroy. And I think it's process file, and we give a name to this event. Paperclip attachment. No, Paperclip process file. Let's call it like that. Okay, let's make it multi-line. Why this method? That's something you can discover from the stack trace when we found that we have the system calls, like Paperclip run something. You can go all the way up to as close to the active record, I would say, to monitor all the possible branches of this file processing feature. Okay, Paperclip attachment process file, Paperclip process file. Let's check that it's okay. The order's not that there. So that's all compile fault. Okay, it tells me to use. Okay, so the first one is a class you want to patch. The second one is event name, and then the method name. But actually, why the order is like this, because you can actually add more method names and profile them using the same event. That could be useful. There are multiple entry points to some heavy lifting code. And yeah, that's the first thing we need to do. And I think, yeah, another spell is a bit more tricky. So we're going to use Stackprof profiler. Stackprof is a profiler that is kind of RSpec specific. No, actually not. We already have support for Minitest. So it helps you to profile different types of tests in your test suite independently. It matter that time and the time that's spent in particular events. Like here we have SQL active record. This comes from active support notifications. Factory create is a custom event added by TestProf. It's profiled the factory's usage. Sidekick inline profiles the amount of time spent performing inline Sidekick jobs. And Paperclip post process is a custom event we just added. And yeah, that's a long command, and there is no kind of configuration file to use for running profilers yet. And it will show us how much time each group of tests, like requests, models, controllers, occupy, and what is the most time where do they spend the most of their time. And we're going to talk about it in a second. Okay, let me continue with a recap for the first part. So what we found, we disabled coverage, we disabled debug jam by default, and we enabled caching for Webpacker. Okay, and that's few things we fixed, but you can try to, while I'm talking, you can try the whole test suite and see the difference from the numbers you had before the workshop. So in my case, it was, okay, let me find my form. It was, oops, it was minute and a half out of 850. So pretty good. Okay. I haven't talked about logging. That's an interesting thing. You probably heard about like a disable logging in your tests, but actually today, if you have faster disk and if you're using Docker and it's configured properly, you can take a look at our compose file. We do not write logs on the host system. We write it within Docker, and it's fast. And there is no difference. So, but still, I prefer to disable logging in test because I don't need to have this file with logs. Like, it's useless. We found that there is potential bottleneck loading thousands of YAML files. Partially, it's handled by Bootsnap. If you're not using Bootsnap, you will definitely notice this overhead of loading thousands of YAML files. I even wrote a blog post like many years ago, but it's an interesting story about Faker because it has also a lot of locales, and they all load it when you load Faker in your test. There is a workaround to disable it, but actually using Bootsnap is good enough. Okay, so what else? Yeah, that's some random facts, actually. I'm going to repeat them. Let's move to focus profiling. That's what I'm talking called using TestProf and narrowing down the search of the problems. And why so? Why do we want to profile different types of tests, kind of isolation? Because from kind of our years of practice and experience, it turned out that similar types of tests, like controller tests and model tests, they have similar problems. They have similar patterns you use in your code, similar setups or whatever. And the fixes are also going to be identical to the whole group. But between groups, they could be different. And that's why it's useful to focus on some particular group, the most time-consuming group, or several groups, and optimize them. Like if you have if a dozen of workers tests and they are slow, but you have 1,000 of controllers tests, they are faster, but together give you like 99% of time, you shouldn't worry about optimizing the slow worker tests. You should find a way to optimize your controller or model test with a few modifications. So that's the same that I said initially. You don't need to optimize outliers. You need to optimize the environment, the setup, the context. Okay, and yeah. So what is the result of the command I showed before of the Stackprof? In its HTML form, it also has a text representation, but I like this HTML view. It shows you how much time do you spend at every group, every type of your test. And you can quickly, using this chart, identify what are the most time-consuming groups in this test suite. And it's requests, models, services, and controllers. They all together occupy about 75% of the whole time. Everything else, just forget about it for the rest of the session. We're going to optimize these 4 groups one by one and trying to make them faster. And that helps to speed up tests quickly because you don't need to worry about different concepts. You put yourself into the context of request specs. Okay, I'm focusing on requests. They all have similar features, and you quickly identifies the patterns that causing slowness, and as a result, you come up with a solution for that. So that's Stackprof. You can try running it and see your profile. It's going to be about the same in terms of distribution of time. And what we're going to do, we can actually start fixing stuff. So we added this event prof, and let's try running the event. Let's get more information about the paperclip overhead, for example, for model specs. For that, we can run event prof as always. So we call it paperclip post process, right? And let's try running all model specs. Our spec models. Okay, probably gonna take some time. So I'm gonna open a new terminal. It's running slow. Why it's not? Okay. Oh, it's not a terminal. Why? Wow. Okay, it was an editor. And we can run in parallel a sidekick profile using event prof sidekick inline. This event is also coming from TestProf. You don't need to add it manually. It's already added. And let's profile request specs. Okay. We need it here. Some failures. That's interesting. Okay. Probably. Oh, yeah. Okay. That wasn't a good idea. The thing is, they share in Redis instance, and there are a lot of stuff depending on Redis, like cache, and that's why we see some tests failing, because there is a shared state. But anyway, we need to see. Okay, we don't have any time here. Paperclip post process. Oh, I called it differently, right? Process file. Okay, let's rename it to. Anyway, yeah. I think I used post process in my slides, so I know why I had it. My bad. Okay, while it's running again, let's take a look at Sidekick. Let's just do some find. Sidekick, okay. Yeah, this one. So what we have here, we have kind of typical setup, maybe a bit different, because usually you see Sidekick configured globally outside of the before hooks. But here we have it set to inline for every test, before every test. And the reason for that is that we have some tests already in the system. Yeah, like using fake, and they just place it right into the example to, I don't know why. Okay, I don't care about the code base. That's a benefit of doing profiling work. You don't care about what is going on there. You just consider code as mostly like it's like entities, some kind of random entities. So having fake dropped here and there to disable Sidekick in place, and to not care about resetting it back whenever you add fake. They just reset it every time for every test. That's okay. What are we gonna do here? Okay, here's our results. Let me show. So yeah, Sidekick. Total time 24 seconds out of minute and a half. 25% for request specs spanned in Sidekick. It should be easy win if we turn fake mode on for requests, and we have some slowest stuff if you want to optimize them one by one. And okay. This stuff is not working. Okay, we'll come back to it later. Oh, I haven't run it again. No, I run it again. Oh no. I haven't restarted. So what we can do, and the process of changing something like that affects a lot of tests, we can change the configuration gradually for particular types. For example, let's add something like temporary variable, Sidekick, fake types, and start with request. And here in the before block, what we can check if the example metadata type and sidekick fake types, then we're going to use the fake mode. Otherwise, continue using inline. That's how we kind of gradually refactor our code base. You can't do that like, okay, let's go fake all in, but likely you're going to have like hundreds of tests failing. That's not a big problem, as you're going to see in a minute. But still, with Sidekick, it's easy to fix. With some other stuff, it could be more complicated. And as a general approach in changing some configuration stuff affecting many examples, I would recommend going this way, like picking a type, profiling it, figuring out some problems, and then apply the same to another type and another. And at some point, you gotta remove this Sidekick fake types stuff and enable it globally. Maybe not really globally, but for most of the tests. Okay, let's try to run. Okay, has it finished? No, I don't know why it's not working. Okay, let's debug it later. Live coding sucks. Let's try to run it again for requests. That's also okay. Let's do this fail fast. Not wait for failures, because I think they're gonna be failures. While it's running, let's talk about paperclip. So we know that maybe the method is wrong. Paperclip attachment, paperclip process file. Okay, I need to go to our Vernier profiler and see where it's being used. We can actually paperclip. No, search not working. Let's try it here. Paperclip attachment. Yeah. Oh, it's post-process. Okay. My mistake. So the method I was looking for is paperclip post-process, not process file. Okay. That's why it's not doing anything here. Okay, we're almost done with Sidekick profiling. Oh, tests are passing. Why so? I was expecting them to fail. I think, yeah, that's a typical Ruby problem. Metadata type, is it string or is it symbol? Let's make sure it's string, because we use strings here, right? I think that's the reason it's probably a symbol. Yeah. You never know. You should probably drop debugger and see what it is, but we disabled it and it's, yeah, funny. Yeah, we know how to enable it anyway. So, okay. For which metadata type? Is it example metadata type? I think it is, right? Yeah, they're using symbols. Okay, this is a nice trick for RSpec. So RSpec has some default support for type inference for specs, but only for known types, like Rails way types. If you have some custom folders, custom abstractions, you need to manually configure RSpec to define this metadata type tag, and that's a snippet that's actually from TestProf as well. You can drop and it will just add metadata type to every example based on the location. Yeah, just one example failed, not that much. Oh, okay, fail fast. Okay, we use fail fast. Again, and that's what you're gonna do. Okay, some examples failing. Let's go fix these examples to use Sidekick fake. No, we're not gonna do that because I can open it and favorite the status successfully. I have no idea what's going on here. Like, I don't want to touch any business logic related code or test code which tests business logic. Instead, what I'm gonna do, I said, okay, let's say this one is Sidekick inline. And in our block here, so we add another check. And okay, and exam. No. Maybe this, right? Sidekick is not inline. It's ugly, but anyway, let's try to run this spec we just found. No. Okay, my bad. So yeah, okay. Let me do some explanation thing. I added this F to it, like it's a focused it. It's one of my favorite features of RSpec. Instead of trying to figure out the line of code and file path, you can mark the test as focused and run the whole test suite, and it's going to be this single test executed, or multiple tests if you mark them all. But unfortunately, it's not configured for this code base. Okay, maybe Copilot gonna help me. Run. Oh, everything filtered. Okay, that's close. Yeah, run. Filter run when matching. That's a magic spell. I'm pretty sure it should be by default enabled in RSpec, but it's not. Okay, let's try it again. Yeah, just one example, and it passed. So we added this meta tag, like sidekick inline, and now it's back to inline mode for this particular test. So, okay, let's remove it, and let's think about it. Okay, we have hundreds of failing tests potentially in the code base. Well, hundreds is not that bad. You can spend like 10 minutes adding sidekick and line manually to each one of them, but that's boring. We know that it's pretty good task for robots to automate, and we have such robots in TestProf. It's called RSpec step, and what we're going to do, it's activated with this rstamp environment variable. We define the tag we want to add. We can use this form for adding sidekick inline, and run the whole subset, like request. And what's going to happen? Whatever a test fails, TestProf automatically adds a tag right into the source code for this failing test. So let's run it and wait for a bit. And let's rerun our event prof here, just to figure out the paperclip story. Let's check again. Paperclip post process. Yeah, it seems so. Okay, there could be probably some, yeah, going to be some false negatives, but anyway, due to this concurrency, yeah, I should have set up some environment variables to use different Redis instances. With databases, we're fine. Yeah, one thing probably I'm not mentioning, but Mastodon code base use transactional features, transactional tests by default. There are a few tests not using transactions, but most of them using transactions. And if you're not using transactions, you're doing something wrong with your test suite, because someone mentioned, I don't know, the CI difference, like due to disk and whatever this morning, that, oh, like writing database on CI is slower than on MacBook. But actually, if you're running anything within a transaction, there is no actual writing on the disk almost, because they all roll back in tests. And then mostly in memory manipulation, you're not feeling a lot. And transactions help in many other ways. So keeping your tests isolated, fast, well, and it's kind of safe to use. So models. Yeah, now we have some data for paperclip post-process takes about 40% of time in the model test. That's a lot. Like, we need to fix it. Let's talk about tag rstamp stuff. So we see rstamp results, total patches, 13 total files. So that means we added 13 sidekick and line tags to the code base automatically, just with this test run. You can try to find them. Yeah, 14 results because one we added manually, and it works. There's some Ruby parsing magic under the hood to just correctly insert a tag into the example. But now if we try to run our request specs one more time, the test run is going to be green. So we improve the performance by switching to fake mode in Sidekick. And we're going to see by how much, because we had, as I remember, 25% of time in Sidekick. And for this setup, it's going to be maybe 2-3%. Let's see, because we just have 13 examples out of 1,000 relying on Sidekick and line. And that's, again, the major principle of refactoring tests for performance. You do not rewrite tests themselves. That's not worth it in most cases. You just make them faster by reconfiguring the setup. And that's, again, why I like RSpec, because it could be done with just tags. They're really useful and powerful. Sorry if you use Minitest. There are some extensions like Minitest tags, but they're not as good as RSpec version. So, and there is no like RSpec stamped version of Minitest in TestProf, so you have to refactor everything manually. So the test is green, and we have like 2% of time spent at Sidekick, and we had 1.5 minutes, and now it's about a minute. So 30 seconds win just for this group of tests. So what's the next goal? The next thing, we add like models. Model, actually, it's going to be model. Check if there are any failures, stamp them, continue. And we continue with this process for every group. Sorry. Or you can go ahead and just run the whole test suite with the rstamp, Sidekick, and line, and that's going to work. It's not that big. So we're not going to do it right now. Yeah. Oh, so yeah, that's me. Make it model line. Sorry. Okay. So we're not going to do it right now, right? You can try it yourself and measure the effect of disabling Sidekick. It's going to be huge. Similarly, paperclip post-process. We figure out that, okay, there is a problem with post-processing. Let's do the same trick here. I just copy this. Let's go paperclip stop types. Let's start with model. Okay, it's paperclip. Stop types, and we will probably need some processing, some tests. So it's nice to have a similar convention here, like paperclip process. But now we need to figure out what is fake and inline for paperclip. As I mentioned, there is no official test mode support in paperclip. There are two options. I think I will just try to, okay, thank you. Yeah, almost. But it's not correct syntax for RSpec, right? But that's a correct hint. That's one of the way of doing this. We can, how it's like allow any instance, right? In RSpec. I don't know what syntax it says. It's like Mocha, maybe. Any instance of paperclip attachment. To receive, yeah, it sounds like a sermon. To receive, post-process, and return true. Actually going to be using post-processing. That's a Boolean kind of predicate method indicating whether we need to post-process or not. And the reason for that stubbing is not compatible with module prepend used by EventProf to add instrumentation. So we cannot, like, that's a kind of limitation, because they use kind of old school alias meta chain style, and it doesn't play well with prepending. And yeah, I think that should be enough. And that's the technique used by the Mastodon code base actually to fix this problem, post-processing. Okay, and let's run again. So we had 1 minute overall. Now it should be faster. And we're gonna see some failed specs for sure, because we haven't added this paperclip process tag anywhere. But let's see. Looks good. Okay, I already see that it's not working because you see that sometimes the tests are freezing. That actually the tests that doing paperclip processing, some heavy processing, they have some tests for MIME types inferred from files, so we cannot skip them. Let's see what's going on here. Paperclip stop types. Metadata. Maybe the syntax for paperclip attachment is not correct. What do you think? Any instance of paperclip attachment, or maybe okay, let me quick check the source code of paperclip. Attachment. Hey. Okay. Post process. If post processing, no, it's correct. It's post processing. And it's paperclip attachment. Something wrong with this rspec spell, I think. Okay, let's go not the easiest way, but I think the proper way. That's paperclip testing fake. That's actually how I usually do when I see paperclip in the code base. We just introduce a custom paperclip testing module. It's gonna take us some time. Paperclip. Testing. Or you can take a look at the original Mastodon code base and copy their snippet for processing if you want. Okay, that's just fake true false fake. That's enough. And yeah, nice. Not super, just return true. I know why true, but let's go this way. Okay, you can skip this part. Like, you know, you can try building it, but it's just a matter of monkey patching. It's up to you how to do that. So testing fake, testing real. Let's add some puts debugging. Fake paperclip. Okay. Okay, let's run a sample, right? We have sampling feature enabled. Okay, yeah, it seems to work. But yeah, and now we have a failing test. It definitely works. So what we're gonna do next is, you probably guess, doing rstamp, paperclip, process, and let it go. That's how we code this. Yeah. Oh, I should drop it. You know, it's easy to monkey patch the class, then use rspec stubbing features. It's pretty straightforward and has less side effects. So, and the same thing, you add new types, you repeat the process until you fix everything. And then maybe someday, because this spec that's still gonna use paperclip processing, I'm gonna be really slow, and maybe it's worth investigating and trying to figure out why they need processing and probably moving it somewhere. I would actually go with one technique of extracting this MIME type configuration or whatever they do with system commands into a tiny gem covered with tests and use it in the code base. Like it could be even local gem, but you do not need to run its tests all the time for all the builds. That one of the kind of architectural technique to isolate slow tests and run them independently. So we have some failures, obviously media attachment spec. They all, I guess, rely on processing. But now, what was that? Yeah. Let's see how fast they're going to be now. Yeah, cool. So this just kind of two examples of changing configuration and gradually applying these changes to the test suite. There are other examples, I think, like usually it's related to file processing. Another example could be any gems you use for auditing your active records, like paper trail. The same technique could be applied to paper trail. You can disable it globally and then enable locally for those tests that really need it. Usually there are just a few of them. So that's another class of tools you might have that could be fixed in a similar fashion. That's interesting. Still not working. But most of them work, and we still have 30% of time compared to like almost 50 we had, just because the media attachment spec itself is the slowest test file in the whole test suite. One quick trick I'd like to add to the project is a new file. Yeah, we don't need this anymore. Okay, let's keep it here. Okay, new file, found the root of the project. New file called rspec-local. So it's your personal rspec configuration file. It should be added to the Git ignore. It's not added on the project, but anyway. What we're gonna do here is we're gonna exclude paperclip, process, test for the rest of the day because we cannot really optimize them a lot, but they would just slow down our test execution for like model specs, which we're gonna do next. Let's probably also fix, well, we're gonna be talking about what's next. I'm gonna fix requests, controllers, what else? Services. Yeah, I think these are the three groups we're gonna work with then, and let's just make them faster. Yeah, question? Oh yeah, sorry, unfortunately I don't see the part of the video. Yeah, if you have questions, just yell. Yeah, I'm gonna share it. I don't know. Okay, let's decide it in Slack later. I'm probably gonna share it on GitHub or whatever. Monkey badge for paperclip. Okay, that's a whole monkey badge. So we have it's a kind of testing module just to keep track of configuration, and we prepend the post-process method with this check, like short circuit execution. Yeah. Okay. So while it's running, let's go back to the slides. Probably I have some slides. Yeah. So why we're doing TestProf, just to continue profiling within a particular group, to kind of figure out what the problems, and then we extend the technique to the whole test suite. So yeah, we tried, we tried an TestProf. It's usually used really once to figure out the direction in which you want to continue profiling. And maybe whenever you start a second round of optimization, you use it again. And we tried EventProf and rspec stamp. They were really useful for us. Okay. So yeah, so we turned off sidekick and line mode by default and disabled paperclip processing wherever it's possible. The technique is described in the blog post, actually a pretty old blog post, the first blog post on TestProf, but it's the same technique still works. It gives you the same sidekick and line example with a bit different implementation of this inlining thing, but you can recall the idea from this blog post. So, and that's we already covered this too. Okay, that's a plain view of the TestProf profile, the same as you see on the chart, but in the table view. And that's my data I collected. I specifically added a factory create event to the list to demonstrate that we actually spend most of the time creating data. Well, that's the trade-off of using factories in Rails test suites. Yeah, fixtures faster, but Rails fixtures hard to use for that side of the project. I wouldn't use it. Maybe the new thing which is created by Casper, and you're gonna check it at the hack day called Arcan, is kind of a better solution because it's a mix of fixtures and factories. But we deal with a legacy code base. We are not in the position of switching from factories to anywhere. So we need to find a way to figure out how to minimize the effect, the overhead of using factories for the code base. So factories. Let me quickly check what's going on with my test suite. Okay, we've finished. It's OACAN, or OACAN. Yeah, like, yeah. That's interesting. And we don't have any failures here. Let's do the same for sidekick and line while we're talking. OACAN, maybe, yeah. I don't know what does it mean actually, but that's a good opportunity to join Casper and visit his table after the talk. Okay. 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 So yeah. Workshop instructions. So what we're gonna do, we're gonna use FactoryProf next. It's a specific profiler that shows you how frequently you use particular factories and how much time do they kind of occupy in the test suite, including kind of self time and nested time, because you have associations and some kind of nested factories. And typically nested factories, yeah, you can try it. We can combine both profilers, VenProf and FProf. It's kind of, you can mix them and try profiling your models. But usually there are several reasons for slow tests due to factories. First one is factory cascades. Factory cascades is a situation when you have kind of a chain calls of factory. Like, usually it's happening with factory body in association. You just define like, hey, factory post, it has user, it has comment, and comment has user, and whatever else has user, and it end up creating a dozen of records for a single create call. And it actually, in most cases, it usually violates the logic of your application because most of these users or accounts must be the same. But it could not be caught by your test, so it's going to be operated on not kind of on invalid state of the data in terms of logic. But that happens, and that leads to a really slow test. And another two reasons is creating too many records just for the sake of a single example and kind of not reusing them, not recycling them. We're going to see how we can do that. And also the popular thing, like creating everything instead of like just building an active record instance without touching a database. It also could be a reason for some slowness, but in practice for larger projects, it's usually negligible. You can ignore it. So we have, again, a post dedicated to factory cascades. And yeah, we're going to see if we have them in Mastodon or not, and talk about this right now. Okay, I think, have we finished here? No, almost. Okay, I don't see any failures. That's strange. So factory cascades could be, yeah. Ah, shit. That's a good catch. Yeah. Okay. Let me think. Whether I need it. Well, let's. Yeah. I think we will have another opportunity to patch all the tests, but right now, you're right. I forgot about adding service and controller here. Same thing here. So, yeah, we wasted some time for that. We have 30 minutes. Okay. Yeah. Okay, let's first run this factory profile. FProf 1. How is it? Event prof. factory create. Factory create works with factory bot and fabrication interchangeably. So yeah, Mastodon use fabrication gem. It's not a factory bot. I don't know who else used fabrication, by the way, at that project. Okay, that's a good opportunity for you to learn something new beyond TestProf. But for our use case, we don't need to worry about the difference. They're the kind of the same create stuff we're going to deal with. You had a question.
Circling back to the first thing you mentioned, how do you consider like the trade-off with the data from providers? Does that mean that every software now has to do it?
Well, yeah, there are options. First, we already showed this RSpec local stuff. You can just drop error debug, and if you use it frequently, you have it enabled automatically. It's not really a big impact for running like few tests when you like iterating. It's bigger, like it's some impact on the whole test run, on CI probably. It's more important to disable it because it's not needed there anywhere. And another option, you can just drop like what I have. It's not working for some reason in this file because it's not really okay. That just require debugger, and that's it. I'm using debugger this way. I don't know if you're using some kind of IDE integration, which is probably require you to have it running, then your option is just running it with RSpec. Be RSpec. Let's try what models? Shall we try models? Yeah, like I don't know why they're failing. Maybe some internet connection. I don't know. That's interesting.
Well, I know why they're failing.
Hmm?
Those tests are in shared examples. Can't stand.
Oh, they require file processing.
Yeah.
That's a good point. Let's fix them actually. Yeah, there are a couple of shared examples. It's something like account header, this one, right? And we can just add sidekick. No, it's sidekick. It's paperclip, right? Process. Thank you. And account. What? Avatar. Yeah. I think this was base 64 only, so I remember. Process. Okay, thank you. So what we have here, we have a pretty long. Oh, it's not really okay. Pretty long list of factories used. Most of them used a few times, but we have four most used factories: account, status, notification, and user. And we can see that total number of usages, top level, it means that it's called, the create is called right in your test example. And non-top level, it means that's code from the factory. So it's like it's a cascade actually. It's small cascade. And we see the total time span, time per call, and some other statistics. So you can see there are some popular factories. Like account is being created. How many examples do we have? About 1,000. So it's being created 1.5 times per example, which is, well, a lot. And status and notification as well. So we can see some basic information, some total information of the time used, and so on. But this kind of flat view doesn't give us an idea whether we have cascades or not. And for that, we have a different mode called flamegrph. Well, it turned out that flamegraphs as a kind of idea could be applied not only to stack traces, but to any kind of stacks. And factory cascade is nothing more than just a stack of factories created within a single call. So we can apply the same technique, we can apply the same tooling to visualize them and quickly identify the cascades. So it's generated as a separate HTML file. We don't need to load it anywhere. We just need to open it. It's no, it's not factory HTML. Okay. So this is a flame graph of your factories. We can see that, okay, notification is calling account, and sometimes it's calling status, and it's also calling account. There's actually nothing bad here. We have some long stack, like not so long, there's 5 items on it, 3 times account created and identification request. Well, I don't have enough domain knowledge to quickly say, well, it's not good or it's good. Well, I don't even know what account is. But anyway, we see that the width of the kind of column is a frequency. Like the more such stacks you have, the more frequent they are, and the height is a height of the stack. And we see there are no actually like cascade that worth fixing because they're all like 1 to depth to one of the two of the size of 1 or 2. So I don't know, unfortunately for us, because we don't need to deal with this problem with this code base, but luckily for Mastodon, they don't have this problem. It's probably a bit harder to introduce it with fabrication than with factory, but probably it's not kind of popularized there, this approach. But whenever you see like skyscrapers, tall skyscrapers like New York City, that means that you have cascades and you want to fix them, and you can find which factories are being affected by that. But that's something as described in the blog post I mentioned before. So we don't have cascades. We have just popular factories. Let me do this stuff while we're talking about. So, okay. Yeah, it's still, okay, it's okay to fail because we're running this mode. What are we going to do next? So we know there are popular factories. Let's try to figure out what they're doing by just looking at the code. And for that, I'm actually going to take a look at the request specs. Let's open some random request spec. Packup spec. You can see that they're pretty well written, easy to read. So we have let user, fabricate user, sign in user, and so on. We can open some other spec, like something like disabled or not related to. Okay, there are no users like invite spec. We have fabricate invite, nothing interesting. Okay, I need to find something interesting. Okay, let's go to API. There are much more controllers here. So we have fabricate user, scopes, token, headers. We have fabricate user, token, headers. And we're gonna have about the same stuff in almost every file. So, and that's why again, it's useful to focus on a particular group. We can spot that there's a pattern. Most of the tests are written in the same style, and most of the tests define a user as a context because for requests, we always need a user. And usually there's also an account. We can just try to do some. So it's fabricate. Account. Stuff, right? And requests. No, not really. Just once. Okay. What about user? No, true. Okay, let's try another form of fabrication. Create. Okay. Let me. Status. What I'm doing wrong. I have a lot of files showing me this stuff. 89 results, not that much. Without count. So what I'm trying to figure out, how popular this pattern. Okay, like fabricate account is really popular, and we see that it's happening in many times in let with exclamation mark, right? So typically, what we can learn from, okay, we fixed this stuff, and now let's fix this stuff as well. From the factory prof profile, that if you see some factories being used by every test, almost every test, there's clearly a pattern used in this test, and it's usually just defining a default context record in your group and your file and just reusing it. The problem is that you create it every time, but in practice, if we use fixtures, we just use the same record for all the tests, right? And we could just simply cut all this like 20 seconds of time out of 23 seconds because for creating like account and status and user, right? The test would be much faster, but we cannot fix it by switching to fixtures. Instead, we can do the following trick, I would say, like refactoring. It actually could lead us to fixtures eventually. And I want to quickly demonstrate it. So, okay, I'm not going to redoing the analysis I did before, but I found that for request specs, we have account and user records created almost for every scenario and defined like at the top level without any modification. So it's just fabricate account and fabricate user. And the same for model specs and others as well, actually. What I want to do is I want to kind of make this approach more official, like make it a part of our best practice in writing tests and extract this into a shared context. So instead of writing at every file, fabricate account, I want just to drop, let's say, a tag. Again, I'm going to use RSpec tags called account. And that's it. It's not going to do anything. Let's first define this. Shared context, where are we going to go? So we didn't have context folders, and it seems that not using context at all. Let's define a new file. Let's call it shared RB. And RSpec shared context. Let's call it shared account. And what we're going to do there is just define the slat account. Yeah, fabricate account. And then we configure a spec to automatically include this context when there is an account tag present. And we can repeat the same for user. That's a good question, whether this user and account must be kind of connected to each other because they relate to each other in the system. But again, I don't know. I'm just following the patterns from the code base, and in most cases, they're just separate records. They're not connected to each other. And let's try to. I have a specific spec like selected for this experiment. So here we have account, and we just drop it. We can drop it. There is some manual work. I wish I could write some tool processing your test suite and doing the same as RSpec stamp, removing the manual definition and replacing with a tag, but I don't have it yet. So yeah, there's a lot of test examples here, shared examples, whatever. We just replace it with a tag. Let's do it somewhere else. I just picking random, test suites. I think we can do it at the top level and drop it here. So that's the process. That's more routine process, but I'm going to show you what it gives us. Right here, okay, just a few of them. Let's start this spec. So let's see how fast or slow it is. Are we still running? No, we fixed everything. So it's ours. Okay, we configured focused specs, so we can just do this. It's some kind of import functionality, and it takes like about 3.5 seconds to complete this. Well, we didn't add any optimization yet, right? We just did some minor refactoring, extracted common used patterns into shared context. And the reason for that is that now whenever you apply this context to all the places they're applicable, so that would take some time, you can optimize the context instead of optimizing each individual file. And how could we optimize this account and user creation? We didn't have any ideas. Well, one of the ideas, we can actually add Rails fixture and call like fixtures, like accounts default, right? Something like that. And user default if we had fixtures. But for the record, I tried adding fixtures to the project and using kind of similar approach, but it turned out that there are a lot of specs relying on the clean global state of the database, especially when it comes to users and accounts. And I decided, okay, that would require a bit more time to refactor and fix. And yeah, that's probably going to be beneficial, but that's definitely not for a 2 hours workshop. Instead, we're going to use some tool from TestProf. And the tool is called Let It Be. So what we're going to do is do this. Yeah. And we also need to activate it. It's not have it by default. I don't know why. Actually, we should do that. So it's also a recipe. So we call TestProf. Yeah, finally. You know, Copilot always suggests adding let it be because it's the most popular tool out of the TestProf toolbox, and it's available in many open source code bases. So we did this trick, right? And we added some let it be stuff. Let's try to run our test again and see the difference, and then we're going to talk about why there is a difference. Woo! A second and a half. So before it was like 3.5, and that second, like 2 times faster, just with this tiny change with this single file. Like it's like 3 seconds compared to 1.5 seconds with just 1.5 seconds, which seems to be nothing. But if we go further and apply this tiny kind of fix to more tests, the cumulative kind of improvement gonna be like minutes. And in my case, okay, let me check my file. Yeah, it was about a minute of time, and I went from 3:30 to 2:30 with the final result when I applied this trick and a few other tricks we're gonna learn. What's it doing? Yeah, that's a question. Okay, it's making it fast. Why, right? Okay, let me rewrite it in a pure RSpec, right? To explain what it's doing. It's doing the following. For all account, fabricate account, let account, kind of. So we create this record once for the context, in our case, like for the file, and reuse it. And yeah, if it was that simple, everyone used it with plain RSpec and had fun. But what's the problem with this approach? The first problem is this one, no transaction. It stays in the database when you call before all. Another problem is account can become dirty, right? You can change its instance, state, whatever, like reload association, like many things, especially if it's a reactive record. There are 2 problems here. And the first problem is also solved by TestProf, because TestProf comes with before all, different version of before all, which is transaction safe. So it opens a transaction for the whole context. And then it opens a new transaction for each particular example. So it's the property of being transactional for every particular test stays. And you also have the property of being the context transaction safe. So you don't need to care about dealing with data and so on. So we can use before all as a replacement for before. In almost all cases, it's just going to work fine and give you this improvement of setting up things once. So I call this feature like let it be and before all, they're kind of companion, and one is used to inside another. It's kind of local fixtures. So that it's just like fixtures, but within this particular file. And the context is right in front of you. You don't need to worry about linking it outside of this file. And if you have dozens of examples, that speeds up things very, very drastically. So that's kind of first step. And let it be is a bit more complicated. So it hides all the instance variables from you. You're not gonna find them and accidentally hit them because we use emojis as instance in variables names. So, and no one used them in the code base. And another thing, which is not yet configured, let me try to, let me check if I have an example that is not working with this. I think, unfortunately, I don't. Let's try to run all the tests we have with the account tag and see if some of them would fail, because we still need to solve the problem of having it clean for every example, having a fresh record. Yeah, we have some failures, right? Yeah, couldn't find, oh, that's, okay. Yeah, this one is not tricky. Couldn't find account status, where starts ID. Something is broken here. So what we do with LDB has support for some kind of modifiers. And the only one you need to know, I think, for now, it's called refined. What's refined? Refined results in the following let definition. it's not like getting user state, like created for the state, for the context, but it's actually getting user find user ID. So we get in a fresh active record instance for every example. We guarantee that it's not polluted with any state changes from previous examples. And finding and restoring a record is 100 times faster than creating a new one with factory and persisting in the database. So that's what refine does. Let's see if it's gonna help with some failures we already have, which is activity map. It's interesting. Where is we change it? I don't know. Let's try. Yeah.
It seems that the refine true would be a default.
Yeah. Yeah. We're gonna go to this place. Yes.
Is it off though in your tooling?
Yes, it is possible. It's gonna be default in the next major version. Unfortunately, we haven't changed it for the V1. So for now, what you're gonna do is, no, not event prof. You need to configure it. Let it be configured. No, yeah, there are other options. Actually, you can redefine. If you don't like Beatles and let it be, you can call it like prepare. That's what Discourse use for that code base. That's the same helper, but just renamed. But I'm looking for, don't stop it. Okay, let me take a look at the documentation. I don't remember it. So let it be. So, okay, modifiers, custom. You can add, yeah, there are a lot of stuff. Yeah, okay, that's what I was looking for. Default modifiers, refine, true. That's it. So that's basically the default setup should be like that. You can always call refine, and refine is smart enough to not call refined on non-active record objects. It's smart enough to call refined on arrays correctly. So refining every element of array, and yeah, going back, and it's gonna help. So I don't want to deal with like why the test failed because I've adding let it be. In most cases, add and refine fix this, but there are some that should be fixed manually, and we have 10 minutes. Okay, that's the most funny part. Let me show you one more example. One more interesting test. That's one more interesting technique. We haven't covered one more profiler. Final one, and it's called RSpec dissect. Not the good title. I don't know. Maybe you can suggest another one. So it's RD Prof 1. Okay. I don't have this. You have it. Right. RD Prof 1. Let's do this for request specs. And I'm going to quickly tell you what is it. RSpec enabled. So this profiler tracks the time you spend in before and let hooks in RSpec. Why it's important? Because it quickly shows you where you can replace let with let it be and before with before o. And we're going to see it in a few seconds, right? So we just run this profiler, pick the most time-consuming files in before and before o, replace with a corresponding helper from TestProf, and that's it. That's kind of the process. And the first one on the list, we're running on a request, right? They're going to be... So caching behavior request cache spec. And we see this 14 seconds, and we spend 30 seconds out of it within before each hook. So we're actually setting up data for every example 95% of time, and then we just verifying that it's something works. I don't know what. Again, let's take a look at this test. Cache spec. There's some shared examples. They're heavily using shared example, and yeah, this is probably the before block that's of our interest. It's creating some records. Let's change it with before all. Let's quickly take a look. What else do we have here? We have Alice, find by name Alice. Okay, that's good. That's okay. And they're just mostly, yeah, nothing interesting. Probably we can replace this with let it be, but not a big deal. Okay, yeah. we can actually check also let definitions here with some names also, but the before hook is what's more interesting for us now. And let's try to, so it was 14 seconds, right? Okay, let's spec cache, spec, what's going to be now? Oh, it's 6 seconds. So it's like 8 seconds left just with few charts changed. So yeah, still it's the profiler is not, what I want to add to this profiler is like the exact location of this before hook would be useful because such huge files you need to scan it manually. It's not easy. It's the same for let definitions. We can take a look at another one like count spec. Okay, here we can reuse our shared example. Oh yeah, that's another pattern. If you see something like that, go ahead and just change it to let it be. And that's it. And I think we can also change it to before all. I'm not sure. Let's try. Also, it wasn't that slow, but now it's going to be. I think it should be instant count spec. Yeah, well, it's kind of fast. I probably have some other patterns here worth improving. Anyway, yeah, this font size is not the best one to scan everything. So that was easy. We just changed the method names kind of, and we got a win. Yeah, that's manual process. Again, feel free to write an automation or tell your AI agent to write it for you. That's something actually that could be automated with new boring tech. Let's take a look at a more complicated example. We have this prepared some interesting stuff to work with. API we want notifications spec. Yeah. Okay. What do we have here? A user with some account attributes. We cannot directly use our shared context here. That's fine. What we can probably replace it with let it be in place. Should be fine. Why it's slow? Let's profile this particular example. I added on a list of examples for some reason. Let's check why. Agent spec, and let's try to see fprof probably. To see what kind of factors do we have here. What the problem? But the problem is always with factors. Yeah, it seems to be slow. User and access and account. Not bad. First, okay. Looks like this before we call some services, and they definitely do some like active record stuff and so on, like follow me, favorite, whatever. Let's try to change it with before all. Maybe that's gonna help. No, it's failing for some reason. Okay, we have some. Okay, we need. That's one trick actually. That's good that we found it. So when going from before to before all, it's important to convert all let definitions used by this before block to let it be definitions to make them visible, because their let is only visible within the example context, and we're working within a group context. Okay. That's one thing. And now we're still failing. So, and now we're kind of failing in a strange way because we have some missing data, kind of. And, okay, I'm not going to do a debugging workshop right now. But the thing is, if we take a look at the example, we see that sidekick align is here. But it's only activated for the example. But now we move the context creation upper to the group, and we need to take care of this. And it's probably because of sidekick align, everything is failing. So what we can do here is just, okay, sidekick, testing. Yeah, just wrap it in a sidekick testing block and fix it. I think, I don't remember. It's probably possible to use tags that was before all, but I never did it. I remember someone contributed with adding support for similar tagged hooks with before all, but I never used it before. Okay, yeah, now we're good. Now we're really good. While we're running this single test. But there's another problem with this test. Let me try to find some, okay, let me run more tests. It's kind of hidden when you're running a single file. But the problem is this following and favorite service rely on Redis as a temporary data storage. And if we take a look at the Rails helper, we can see that there is something interesting. Yeah, Redis, delete Redis keys after each example. But we set up data within the group, and whenever the first example runs, it could be cleaned up. So we need to implement some kind of a similar mechanism, but for the group. And before all supports, okay, let's check it. We have hooks as well. They collect before begin and before all back. So we can move the Redis cleanup to the group level for before all affected kind of groups. But we will need also, oh, it's okay, it's passing for some reason. It failed for me previously. Anyway, and we will need to add some check here, like example, next if example, metadata, like Redis, I don't know, keep, for example. So we do not reset it for examples, but instead we reset it for the whole group when the before all context ends. There is some trickery when you deal with complex projects beyond, like, you know, simple RSpec tests, but still it's worth introducing this minor refactoring, and because it's mostly doesn't involve refactoring the test itself, right? You just refactoring the configuration. And one more example I have, I think, no, I don't have it here. Models user spec. User spec. Oh yeah, status is controllers in controllers. So let's try to run it. RSpec controllers. Another kind of caveats with before all and how to solve it. Stat controller spec. Yeah, that's the one I have. Let's open it while it's running and see what we have here. Yeah, it's passing because we haven't changed anything. So we have account and status. So let's just replace it with our shared context and let it be. And yeah, we introduced a new status. That's fine. Original status. Okay. But we have status created multiple times. If we just take a look at the status thing, oh, it's like 12 times we define different status, and the only thing we change is visibility. So we change one property, but for that property we create the record again. Instead of doing this, what we can do, we already created a status. We can actually move it. I think we can move it up. Maybe not, but probably. Okay, yeah, I think we can do that. It's better to define all the local fixtures at the very top of the test file, not in the nested context. So you can easily spot the setup for your the whole kind of context, top level context. And now we have some changes here local. So this is just a single example. Let's not change anything. That's fine. I wanted to show this, yeah, visibility stuff. So instead of creating a new record here for visibility tests, because we have a few tests here, what we can do, we can update the already created fixture. Before, status, update, visibility. And that's why we kind of save on creating a new one. We just update the existing, and it's safe because this before hook is happening with an example and it's being rolled back. So we're good to go. That's one of the techniques to learn when using let it be and before all stuff. So same here. Direct. Yeah, some manual work, but I want to get rid of all the statuses. User, let's use our context. Sorry, we already activated refined by default for all the let it be features. So it's yeah. Sorry? Yes, yes. We just update. We have every time we have a fresh record of the fresh status record. Okay, here are the same private and some manual work. I'm just gonna want to show the difference because the difference is going to be pretty good for this particular test. Well, probably we can add this, make this let it be as well. Okay, and now again, this visibility stuff. Another option could be just creating free records with different visibilities and using them by redefining let. Well, because it's not a big deal. Free against like 1. Okay, we're almost there. Sorry, some manual work. And I think that's going to be the last thing I wanted to show before the final portion of the slides. Okay, I think that's enough. Let's try to run it again. Yeah, well, we kind of cut half a second. Probably proper refactoring would bring us more, but still, it's good result for like a minute of time spent on that. Well, I think let's move on to the presentation because we have 30 seconds left. Yeah, almost on time. And I don't think you want to, skip your lunch. So, FactoryProf and RSpec Dissect are tools that help you to figure out which repetitive data was like reusing. Like I call like recycling is refined as an example of recycling, right? Because we reuse the database state, but we recycle the active like a Ruby object. So it's both good for for the planet and for your test suite. What we found? Well, unfortunately, this code base has no cascades, and we didn't need to fix them. That's good. We considered the shared context pattern. The eventual, like we only replaced let with let it be, but eventually there is one more step. You can replace it with fixture. We have any fixture kind of package within TestProf, which allows you just to wrap your factory into, to create a fixture from your factory. And it also cleans up the state at the end of the test run. So obviously smarter than just keeping it in memory. So that's an ultimate target of using this shared context setup. So eventually we will end up with a single record for the whole test run. And yeah, so I achieved some 6 times speed up for some of the examples by doing this kind of refactoring, but it's required some manual work. So it's like a local work, like hunting these places, refactoring. But the good thing, you can start writing new tests by introducing these patterns, or this rule of if you fix something, make something a bit better that was left before you. So that's a good pattern to follow. Yeah, that's a caveat we just seen. So sometimes you need to update your tests a bit to be aware of this shared records. And yeah, that's probably what I just said, homework. So yeah, so your homework is to try other things we have in TestProf, because TestProf has more stuff. Like the one is Autopilot, is our recent edition, is actually the tool that helps you to like write scripts to perform some automatic profiling, like doing multiple samples, aggregating results and combining them in single JSON, or doing like event-prof and selecting most time-consuming records and doing factory-prof just for these records, like some scripts. We have some examples. Try to make your test faster. Try to bring some contributions to Mastodon. Not everything we fixed today already fixed there. There are some easy things. There is an opportunity to become a contributor, and you can come visit me after the lunch. Actually, before the lunch, I'm going to be meet the authors, and then I have 3 tables and me alone hacking on TestProf and other projects, and I have some interesting issues. One related to Vernier, and which I really want to add, and it's going to be cool to hack around with it. Yeah, that's it. Thank you.